25% of designs reach market on time, on budget, right? 25%, that's not very many. 30% reach the market on time, but require a major surge in resources. So you start to think about the opportunity costs associated with that, and it's pretty stressful. 28% of projects reach market, but outside of those critical market windows, and 17% are actually canceled. You might be wondering, why are the statistics so bad? A big contributing factor is the fact that the whole analysis process and the ability to characterize design performance is challenging. It requires a high level of expertise, and you just can't cover your entire design, right? So that's where the small stuff comes and bites you in the end. So what we want to do in this session is talk about what we can do to improve your design flow, improve efficiency, and enable more of the project team to help. Let's start by talking about a typical high-speed design flow. You guys are all experts, you know what this looks like. If you're doing this day in and day out, it's not a problem, it's just very time consuming. However, because you don't have enough time, you're having to focus in on critical areas of the board. You're picking critical interfaces, and then even within those interfaces, you're having to parse that down into small regions such as breakout regions. Go through and analyze all of those separately, hopefully go into another tool, push all those blocks together to do transient analysis, and then probably extracting your end-to-end channel S parameters once again. And in the end, taking those to yet another tool for channel compliance analysis. Now at Mentor, HyperLynx is really focused on automating this flow so that if you are the expert, you have one interface that drives many different solvers and will help you be a lot more efficient. But what about what we talked about before? All of the non-critical areas, the areas that are the ones that usually end up biting you because you didn't have a chance to focus there. This is the rest of the project team. There's very inconsistent design review practices. Some people will have a formal checklist, right? If you have a formal checklist, that helps a little bit, but you're still looking through complex CAD data layer by layer with your eyes. It's easy to miss things. And inevitably, you end up with a failure in the lab. Now, you're in there sweating, everybody's angry, time is critical, and you're trying to determine what was it that I missed? Probably something outside of where you were focusing on your analysis, right? So now you're really scrambling, you're trying to find that thing that you missed, and eventually you do, hopefully, and you're part of that 25% that does release on time. However, what if you could learn from that and find it time and time again in a repeatable way? So no matter who ran the check, you always got the same results. This is a perfect example. This is an automation platform called HyperLynx DRC. It enables you to encode these rules and find the problems consistently and repeatably. Now, a trace crossing a split is a return path discontinuity, right? If you know the problem exists, you can go off and simulate it and determine the effects. However, finding it is the problem. This shows you how easily you can identify your different violation areas and determine what the fix will be. If I'm a layout designer, maybe I can see the problem and go fix it immediately without requiring simulation. Another example is this return path discontinuity through a vertical reference plane change. Now this is really hard to see because you're looking down at 2D CAD data and it's not apparent, obviously, where the return path will be running, right? In this 3D view, in a simple structure, it's easier to see, but in a 2D typical CAD view, it's not. Here's an example. This doesn't sound exciting if we're talking about simulation, right? But it's a common constraint. Place the cap as close as possible to the IC pin. Very vague, ambiguous, sounds simple enough, but you start to think about it. What's close enough? Is it good enough? And how am I going to get through my whole design? Okay, start by finding a pin, a cap, what's the distance? Not too bad, but now I've got a whole board, right? I've got a real chip with a lot of power and ground pins. That's going to be extremely tedious and time consuming for me to go through, find the IC pin that I want to look at. I probably have to prioritize my rails, then go find all of the capacitors to find the closest capacitors and determine the connectivity, not just the placement distance, but the real connectivity of the capacitors to those IC pins. Changing layers on and off, understanding the connection path through the planes, traces, and vias. And then finally, I'm going to take that measurement, put it in a spreadsheet, and estimate the DC resistance and loop inductance. Okay, awesome. Now I get to do that a million times for every pin on my board, right? It's not fun, and I've got a whole bunch of capacitors as well. So pretty much at the end of this exercise, I go home and I'm hating my job. I don't want to do this. This isn't the best way for me to be spending my time, but it is important. So I have an idea. We can't not check these things, right? But we could automate them. What if we could just simply define our target list of ICs? And the tool is smart enough to determine all of the power pins associated with that IC and the capacitors within that region. So now what happens is the tool has the list of IC power pins, capacitor pins, and power and ground nets. It builds that solver project for me. I don't need to be an expert in the full wave solvers. It's going to execute that and actually generate a report of loop inductance and DC resistance, and then parse those results back into this great spreadsheet view where it's easy for me to sort results. Here's an example where I bring an actual board in. Now I want to make sure that I don't have to do much setup, right? So we want to configure this in a way that whoever opens a board, whatever project it is, it's set up automatically. I select that rule we were talking about the capacitors being close to an IC pin, and all I want to have to do is determine what is my search distance around that pin, right? So these are parameterized. I define the search distance so the tool knows where to go look for those capacitors. And then I have some very simple parameters to set up the source project file, what frequency I want to do, the extraction for loop inductance. And the last thing I need to do is just give it a target list of ICs. But I don't want to go in and set that up every time, right? So I've got some nice filters that I'll show you here. In this case, I'm filtering on pin count, so it's automatically going to pull in my large ICs. But I could be filtering on schematic properties or anything that enables me to get this set up automatically. Once I have those simple parameters set, I'll execute the rule. Here I'm using the GUI, but it could be done in a batch as well. And when it runs, I get that spreadsheet. And when I click on these violations or these entries, it very clearly shows me graphically what the conditions are. In this case, this power pin doesn't have any capacitor within the search region. So it's very easy for me to see. Here's an example where I do have the capacitor that's been identified, but I want to know a lot more than just where it's placed, right? I'll get the placement distance, the straight line, but I'll also get the connectivity path. So I get the connections on different layers, through traces, through vias, through planes. And like I said before, it's actually setting up the whole solve project for me, and it's executing the solve, generating the report of DC resistance and loop inductance, and placing all of that information right here in the spreadsheet. As I select the different entries, it's showing me graphically where all of those different pairs of pins are, and it's also allowing me to generate a report. If I want to report all of them, I can do that, archive it with the design, or maybe I want to export that and send it to a colleague. I've got links for cross-probing to layout, I've got all of the column data and the snapshots in a nice format that I can share with my friends. So like I said, the whole point of this presentation was just to get your wheels spinning on how we can help you make your life easier. Maybe it's an expert design flow that you want to automate, but hopefully it's a way to encode the knowledge that you have in a way that anyone on the project team can help with that design review in a very repeatable fashion.